Okay, so yesterday we looked at graphing with our calculator. We all learned how to write an equation on our calculator. What button do I press to enter an equation? Y equals, very good. So from yesterday, we should have y equals, and then we should have in parentheses 1 divided by 2, and then 6, and then in the exponent, x plus 2 minus 2. I put that in our calculator. Once it's in my calculator, how do I graph it? Push the graph button. Yeah, I want to graph it, I push the graph button. And we wait because it's slow. We did, but we didn't draw it on the paper, so we're going to draw it on the paper. So looking at that shape, to draw it on my graph, I need to identify some features about the graph in my calculator so I can mirror them in my picture. And there are two important points that I see in that graph. First, I see a y-intercept. Can somebody, not a y, sorry, an x-intercept. Where does it look like that x-intercept is on our graph? -1. It looks like it's crossing just behind the origin. So I'm guesstimating that my intercept is right, if I could get my pen to work, sitting right about there. I also see when I'm looking at my graph that it approaches the y-axis, it never touches. The y-axis is an asymptote. So in a different color, I'm going to mark my vertical asymptote. I know it never crosses the y. Does that graph have another asymptote, horizontal or vertical? Does it look like it levels out? Yeah, it kind of bottoms out, right? So the question is, as it comes down and goes backwards, where is it flattening out? So can we estimate from our calculator screen where it looks like that leveling out point is happening? Y equals what? 2. Looks like it's bottoming out at y equals 2. Yeah, so I think that there is a horizontal asymptote here at the bottom of my graph. And I know that my graph goes, that was horribly messy, goes up this way, approaching that asymptote, and it goes down and flattens out this way. A little bit different than how we use that table of values. I don't have points to plot here in the same way I did with my table of values. What I'm doing is looking at my calculator screen and guesstimating where those important features are. Where are the x and y intercepts? Where are my asymptotes? Where is the vertex if it's a v or a u? Yeah, we want to make sure that those points on this screen end up on that paper. Yeah, the finer details you can get a little muddy with. General shape and your intercepts, your asymptotes, your vertices should be there. Yeah. Okay, I'm gonna scooch you over. We're gonna do the next one in Desmos. If you have your Chromebook out, that's great. You can follow along. If you don't, I'm gonna do it on the screen. You can watch or follow along. I'll leave that up to you. But we will do this together. Ugh. You haven't done the homework? Bruh. Yeah, that's the song of the procrastinator, and it doesn't tend to go well. Okay, so I'm logged into Desmos. I'm going to give you just a minute for those of you pulling out your calculator. To get to Desmos, you can just type in Google Desmos, and then select the graphing calculator. And you'll remember from yesterday, when we graph things in Desmos, we type them exactly as they appear on the paper. So I'm going to do that in my Desmos window. F of x equals negative x, and then I need to get a cubed. So I have a couple options. I can pull up the special keyboard, or I happen to know that the caret above the 6 will also take me up there. Plus 3x squared plus 2. And I haven't even pressed enter yet. I just stopped typing and it's graphed it for me. So those of you who have Desmos open, can I get a thumbs up if you got that function to graph? I see some thumbs up. Don't forget the left half, the f of x, or y equals. Yeah. Yeah, good. Some of us are still opening. Good, perfect. Perfect. I want to translate that onto this graph. So I'm going to start looking for points. Desmos is nicer about it than your graphing calculator because we can start clicking on points to get their coordinates. I can see that peak right there is at 2, 6. Yeah? I'm going to start to draw, and I think it's going to kick me out of this window, so I'm going to need your help with some of those other points. Yeah? So those of you with Desmos open are going to help me. But I'm going to make my 2, 6 point first. So 2, 6. Good. And it's kind of making an S shape. Where's the bottom of that U in the middle? 0, 2. So that's our intercept right there. That's the bottom of the U. Very good. And then there should be another peak over here on the left because it's coming. Wait, is it going up and then down and then up? Is that right? Yeah? Where does it cross the x-axis? Where's our x-intercept? A little after 3. So right about here-ish. Yeah? Perfect. So I know that it does the... That is horrible. Mr. J, try that again. I know it does that. I know it comes down and does that. Yeah? Not perfect. Doesn't have to be perfect. We're looking for important features and general shape. So I've got my y-intercept. I've got that local peak where it kind of maxes out before it turns back around. I've got that x-intercept. So if we're graphing with technology, just the important points and the general shape. Yeah? Okay. The other important thing is it's important to know how to use our graphing calculator like we did in number 4, because when you are taking a test, you will have access to your graphing calculator. So if you're unsure what a function should look like, stick it in the calculator. You can check your work that way. Yeah? So make friends with that graphing menu. I would encourage you as you're working through the homework this week to try and graph everything on your calculator, even if it asks you to do it by hand, just so you get that practice of getting it in the calculator and adjusting the window so you can see it. Yeah? When I see you next week and we talk more about function properties and important features, we'll practice more with Desmos together in class. All right. Questions on the technology part? No. Okay. So next little business. He's talking about domain and range. So a quick reminder of those vocab words. Domain is my input or my output? Input or output? Input or output? Show me on your thumbs, input or output. I see thumbs up. Good. Domain is input. That's our x values. So this is the set of all input or x values. Yeah. Which means my range is what? Output or y values. Good. It's the set of all possible y values for the function. There's a couple of ways that we can identify. I'm going to approve them all because I don't know who went first. Go quickly, don't play around. There's a couple ways we can find them. Yeah. There are two that we're going to practice right now. The first is from a graph. Graphs are nice because human brains interpret pictures better than they interpret equations and tables. So from the graphs, the easiest way to do it, if you're not sure how else to do it, graph the function on your calculator. Yeah? The other way is from the structure of its equation. I can tell algebraically what its domain and range is likely to be. We're going to do both because it's important to know how to do both. Yeah. We'll start with a graph. The domain is all of the input values shown on the x-axis, right? Because input is x. The range is all outputs shown on the y-axis. Before we talk about communicating the domain, I want to review some notation that you might see in pictures. There are three things in graphs that indicate limitations to our domain and range. So you may see lines that end with an empty circle. You may see lines that end with a filled-in circle. And you may see lines that end with an arrow. And the question is, what is the difference between those? So have we seen those before? I hope the answer is yes, because you should see that in like Math 2 and Math 3. Good. So what's the difference? We'll start with the circles. What's the difference between the empty and the filled in? Can somebody explain? Very good. It has to do with whether the end point of that line is included or not included. So the empty circle, the end point is not included. Bless you. I swear I know how to spell. I don't know how to write, though. Usually when we're talking about endpoints not being included and we're using interval notation, these are those rounded brackets. These are these guys. Empty circles are rounded brackets. Rounded brackets tell us the endpoint is not included. Filled in circles, the end is included, which means instead of round brackets, what types of brackets should I use? I heard it somewhere. Sharp brackets or square brackets. Yeah, the boxy guys. It is possible you will have a mix. One side is empty, one side is filled in, one side will be round, one side will be square. You can have a combination of both. Yeah. If I see an arrow, what is that arrow telling me? It's still going. Yeah, it goes all the way off the graph and it keeps going. It goes without end. Yeah. In cases where we're going without end, the line keeps going and going forever and ever, we use round brackets and the infinity symbol. If it's going to the left, that would be negative infinity as your lower bound. If it's going to the right, that's your left side, it's positive infinity as your upper bound. If the lines are going to infinity, we always surround it with round brackets because infinity never ends. There isn't an endpoint to square off. So infinity is round brackets. Okay, can I get a thumbs up on how many people have seen that type of notation before? And it looks like that's most, if not all of us. Okay, good. We're going to practice that in a minute. I want to review the other types of notation you will see because there are 3. We can express our domain and range using inequality notation. So for one, an example of inequality notation, I would say that my variable x is between positive and negative infinity. That means that my graph goes forever in both directions, out the sides of the graph. Yeah, that's an example of interval notation, or not interval, sorry, inequality notation. Inequality notation, you're always going to have your variable, an inequality symbol, and some numbers in there somewhere. Number 2, depending on who you had for your math 3 teacher, you may have seen a lot of this one or very little of it, is set builder notation. And I see some nodding. So set builder notation, we use curly brackets. We identify the variable name. So if I'm talking about domain, that would be x. And then I draw a vertical line to stand for such that. And I'm saying all x such that, and then I'm going to give a condition for my x. Where does my x exist? So for example, I could say x greater than 0. My function only exists on the positive half of the graph. The last is the one that I prefer, and that's the interval notation, which is what's up here. The round brackets or the square brackets. Lower limit, upper limit. Yeah. You'll notice for interval notation, there's no variable in that notation in the same way there is for set builder and inequality notation. So you have to very clearly label the interval notation as domain or range. So we know whether it applies to the x or the y. So this one you have to be careful with labeling. This is the one I'm going to stick with the most. That's the one that I prefer because it was the most common when I took pre-cal and calculus. Yay. Okay, we're going to practice identifying from graph first and then from equations. Yeah. All right, so 2 graphs. Do the first one with you. It says find the domain and range from the graph shown below. Express your answer using each of the 3 notations. So I'm going to show each of the 3 so you can see how they relate. Yeah. All right. So for that first one, oh, I did delete that. For domain, I'm going to do my domain on this side. I'll do my range over here. For my domain, I'm looking at the range of x values. Where is my smallest x value? Where is my biggest x value? So let's start with my smallest x value. Where is the graph end on the left side? -3. -3. Good. Is -3 included? No. So I'm going to write less than instead of less than or equal to. Because -3 is just outside the set. It's not part of the set. Good. And then this is domain, so it's x. And then I look at the other side of the graph. What's the largest x value? 1. Is 1 included in the graph? Yes, because it's filled in. So that's a less than or equal to. That would be our interval notation. Set builder notation looks almost identical. Curly brackets, x such that, and then we write the inequality notation. Yeah, set builder is building on that inequality statement. The last one, the one that I prefer because it's less writing. I know my numbers are -3 to 1. On the lower end, round or square? Round, because it was an empty circle. Perfect. Upper end, round or square? Square, because it's filled in. Perfect. Perfect. Good. Same thing for the range. I'm going to do this one a little bit faster. So range is looking top to bottom. My lowest point is right here at -4. And both of those points at y is -4 are filled in. They're part of the graph. That's a less than or equal to. I'm doing the y-axis, so I'm going to put a y in the middle. And then I'm going to go look for the largest y value. So the top of this curve is at 0. And the question is 0, y equals 0, part of the graph? So take a minute, look at that graph, discuss with your neighbor. I'm going to call for a vote on your thumbs in just a minute. Is y equals 0 part of the graph? You guys are so quiet and shy. This is the polar opposite of my third period. Verna says, yeah, let's vote with our thumbs. If you think 0 should be included, thumbs up. If 0 should not be included, thumbs down. Give me your thumbs. I see thumbs up, thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. I think I see universal thumbs up. Very good. I see y equals 0 repeated. Once is an empty circle, but the second time I see it, it's filled in. And that filled in circle overrides the empty. Even though it's not here, it is here. And so it should be part of my range. I know set builder, it's x such that, or not x, oh, Mr. J, y such that y is between -4 and 0. I know for interval notation, my numbers are -4 and 0. I just have to ask myself what type of brackets. Round or square? Square. Very good. On both sides, because both -4 and 0 are included. Very good. I'm going to put about 2 minutes on the clock. I want you to work with your table mates. To do the same thing for number 6, you will have to estimate some of those x or y values, and that's okay. Just dotted line, estimate what those numbers are. Yeah? Give you about 2 minutes, and then we will come together as a class. All right, let's bring it back together as a class and kind of look at our collective knowledge here. So we're going to start with the domain. For the domain, in the graph, where should I be looking? X-axis, very good. I need to track the edges of where the graph sits on the x-axis. And I saw a lot of you drawing lines, which is perfect. We can see from the graph, it starts at about 1950, ends at about 2000. Are those endpoints empty or filled in? Were there empty circles? No, so we assume filled in if we're not told otherwise. Good. So we could have 1950 less than or equal to x, less than or equal to 2000. We know set builder is basically that with some extra stuff around it. We know interval notation is the lazy way. 1950 comma 2000. Round or square brackets? Square. If we include the ends, square. Perfect. Perfect. Very good. What about my range? Which axis am I looking on? The y. Very good. And I want my lowest point, which happens to be my lowest x value, and my highest point, which is this peak right here. And for my lowest point, I'm going to need to do some estimating. Looking at that point, it looks closer to 50 than it is to 40. So it's bigger than 45. Does 48 sound reasonable? I see some nodding. So we're going to estimate the lower bound is 48. And the upper bound we can see is 90. Is the bottom and top of the graph empty or filled in? Do you see circles? Empty circles? No, if there's no empty circles, the assumption is it's included in the graph. They will mark empty places with very visible holes. So I'm glad you brought that up. That's really important. They will make empty spots very apparent. If we don't see any of those big gaping holes, we assume it's there. So we're going to use less than or equal to. Yeah. And I'm going to skip the middle because we know what the middle looks like. For my interval notation, 48 comma 90, round or square? Square. Very good. If it's included, it is square. Very good.
Wait a minute. Let's find the third one. 1950 X and 2000 and the final result is 2000.
Huh?
Just find the
I'm not sure I understand what you're asking. Where are we stuck?
oh, never mind. Now.
Right, these are coming from the red. Those were tracing the x-axis edges.
Yeah.
These came from the blue, the y-axis edges, top and bottom. Yeah. Other questions? No. Okay, reminders, don't be afraid to mark up your graph. Color coding is also helpful. We like colors. And this is just going to take practice, right? Getting that notation right. Okay, I think we have a couple minutes left. I want to go over how to do this from an equation. We're going to do some algebra. So when we are looking at functions, we're going to start by assuming that all values work with the function, meaning all x values from negative infinity to infinity work, all y values are possible out from negative infinity to infinity. And we're going to use the structure of the function to then narrow those down. And we're going to do that by looking at some things that we know we're not allowed to do as mathematicians. So the first thing that we're going to do is we're going to look at our function and we're looking for fractions. This first guy happens anytime we have fractions. Why is this not cooperating today? Come on. When I have fractions or I'm doing division, what number am I not allowed to divide by? 0. Yeah. So we're going to exclude anything that results in division by 0. Look at the denominator, check what makes the denominator 0, exclude that from your domain. Those are values that x cannot take. Next, we're going to look at roots and radicals. I know that I am not allowed to take the square root of a negative number. If I do, I start getting i's in my answer. It makes me unhappy. Yeah, I'm no longer in the real picture. So I am going to exclude any inputs that have a negative under a root. And I'm going to make a little side note. I'm indicating square root because that's the most common. I only have this problem with negatives under the root when it is an even-powered root. 2, 4, 6, 8. Odd-powered roots, like a cube root, I'm allowed to have negatives. And the reason I'm allowed to have negatives is negative 2 times negative 2 times negative 2 is what? Negative to start with, and 2 times 2 times 2 is 8. Yeah, so if I take this cube root of negative, that was not there. Answer right there. If I take the cube root of negative 8, my answer is negative 2. I can take a cube root of negative 8 because an odd number of negatives produces a negative answer. So odd-powered roots, cubes, 5s, 7s, 9s, don't produce the same issues that even-powered roots produce. So when we're excluding negatives under a root, it's only for square roots. If it's a cube root, you don't have to worry about it. It is unlikely that you're going to encounter that in this book because this is just pre-cal. When you do calculus, you start seeing higher order roots. You have to remember the difference between even and odd. Okay, the upside is after you've done step 1 and 2, you should know what your domain looks like. All real numbers except where I have those problems. Yay. And then you're going to look at which values are excluded from the range by inputting your problem answers, right, into that function. Where do those problems occur on the y? Yeah, so you're going to use the input values to determine the range. If you are not sure that you have done this process correctly, how do you check? Yeah, graphing calculator, graph that bad boy. Check the graph. Graphing calculator, Desmos. That graph will show you where those issues show up in the domain and range. So you should try it with algebra, but double check it with a graph. We're going to practice this a little bit on Thursday. Are you guys the ones who still need to do your heart now? Okay, so we'll practice this a little bit on Thursday, and then Hartnell, I think, will come about 15 minutes into our lecture, and they'll get you registered. Yay. And then everybody will all be caught up.
Will we